All right, so now what we're going to do is talk about complementary events. So the complement of an event is basically what it means is if let's say I have a die. So let's say I have a die, and on this die is 1, 2, 3, 4, 5, 6, right? And I want to know so my event, so A is going to equal 6. The complement of A, which we say A bar, would be everything but 6. Okay, so it's just the opposite. So let's read it. The complement of an A, denoted by A with a bar above it, consists of all outcomes in which event A does not occur. So that would be that. And we can do probabilities with this, and we can do what we call odds. So first, let's figure out what the complement of death from skydiving is. Well, this is an exciting one, right? So in recent years, we already saw this. There were 3 million skydiving jumps, and 21 of them resulted in death. So it says find the probability of not dying when making a skydiving jump. So remember we found the probability of dying was 21 out of 3 million. We did that in the last video. So how would we find the probability of dying? And this we could say not dying. Okay, so this is really the probability of not dying. Okay, well, first what we have to do is find out how many ways we're not going to die, right? So if we have 3 million jumps and 21 of them resulted in death, that means that we take our calculator and we can say 3 million minus 21, because obviously the complement is if this is 21 people died, everyone else lived. So that would be 2,999,979 divided by 3,000. Sorry, 3 million. Okay, so the probability of not dying is going to be this number, and I'll put this in my calculator. Yes, so that's going to be equal to 0.9999993, which is almost 100%, right? It's a very small probability of dying. I can't go back to the old slide about dying, but if this is the value, if this is the probability of not dying, then this has to be what we call the complement. And the complement, let's see, 1, 2, 3, 4, 5, 7. The complement plus, so A, where here we can call A equals dying, right? That means that A bar for the complement, not A, is equal to not dying. And that's the only two possibilities. You're either going to die or you're not going to die. So the probability of A plus the probability of not A is got to equal 1. For this, especially since there's only two possibilities, right? And if we add them together, it has to be 1. So hopefully that was clear. And here's that, and then we have exactly what we said. So identifying significant results with probabilities. So the rare event rule for inferential statistics. If under a given assumption, the probability of a particular observed event is very small, and the observed event occurs significantly less than or significantly greater than what we typically expect with that assumption, then we can conclude that the assumption is probably not correct. So if we're thinking that something is going to happen sometimes, and we get this tiny possibility of it ever happening, then first thing we want to do is see if we made a proper assumption. That's basically what this says. So identifying significant results. And these are really similar, so I put them together so we can kind of talk about them together. So using probabilities to determine when results are significantly high or significantly low. So when they're significantly high, X successes among N trials is a significantly high number of successes. The probability of X or more successes is unlikely if it has a probability of 0.05 or less. Okay, so this is basically, this is the number that we're looking for, which is the same as 5%. So if X is significantly high number of successes, for example, if P of X or more is less than or equal to 0.05, then we have a significantly high number of successes. For example, the skydiving, we have a significantly high number of successes because our probability of not dying was equal to, I think there was like 5 9s and then a 7. If I were to round this, I would be rounding it to 1, right? If I would round it to 3 decimal places, I would round this up to 1. And 1 is basically you're not going to die, right? 21 out of 3 million is a significantly high number of successes for living or a significantly low number of successes for not living. Okay. So basically we can use the same exact slide for both. So we have a significantly high, so this number right here, if we want to talk about, I mean, obviously this is significantly high. It's almost 100% chance that you're going to not die. Okay. Now it doesn't say anything about hurting yourself, right? So we're not talking about that. We're talking about living and dying. And that in turn makes the probability. So here we said A is equal to dying. So A complement is not dying, right? So if that's my significantly high number of successes, and I consider a success not dying, hopefully you would consider that a success, then we have a significantly low number of possibilities or of the probability that we are going to die. That's significantly low because that's less than 0.05. And this right here, basically we're saying that the number of, so we're saying here the number of not dying is is X or more. So if we were trying to find 5%, let's do it like this. This may be more helpful. So let's say what is 5% of 3 million? So we multiply 3 million times 0.05, and we get, hold on. $150,000. So we have up to 150,000 people could die, and it would still be significantly low, which seems crazy, right? I mean, if 150,000 people die each year from skydiving, I think we would think that's significant, that's significant, right? But that's 0.05. That's like the upper limit. If 100,000 people die from skydiving, we would call that a significantly low amount, believe it or not, because it's out of so many. I think that's clear, hopefully. If anything that I'm saying you don't understand, please ask. I'm happy to answer any questions. So probability review. The probability of an event is a fraction or a decimal between 0 and 1, including 0 and 1. The probability of an impossible event is 0. And the probability of an event that is certain to occur is 1. And we can also say it's the same as 0% chance or 100% chance. Okay? So the notation P of A means the probability of an event A, and the notation P of A complement is the probability that this event did not occur. And that's pretty much it. So now we're going to start talking about odds. And odds are really similar. We kind of do things a lot the same, but it's a little bit different. So let's see what the differences are. So odds, the actual odds against. So the actual odds against event A occurring is the ratio, and ratio really means division. So we're going to divide two things and we get a ratio. And this says, we're going to first say, because we're looking at odds against, we're going to pick odds against as the numerator. And then in the denominator is odds for. Okay, so I would have to look at this ratio of the odds against over the odds for, the probability against over the probability for something, and we would get a number. Okay, we reduce the number. So let's say that we had A over B. So this right here is saying that the probability of not A is A, and the probability of A is B. Okay, and we can say it's, usually we write it as A to B. We could write it as A to B. That's the terminology. A and B are both integers. That's very important. So we wouldn't have a half to 1. We would turn it into a whole number. And how would we do that? So let's say I said that A over B is equal to 1/2 over 1. Okay, and we want to write it as 1/2 to 1. Well, that wouldn't work because these are not integers. 1/2 is not an integer. An integer is a whole number. It can be a positive whole number, a negative whole number, or 0. That's what an integer is. But for probabilities, remember, we don't have negative numbers. It's just 0. It's just 0 and above. So what could I do? Because this is not okay. We would not write it like this. So I could say we can multiply this by 2 over 2. And then what would we have? We would have A over B is equal to 2 over 1. Sorry, 2 over 2 is 1. Here, I'll write it like this. 2 over 2 divided by 1 times 2. So this is 1 divided by 2. So we don't write it like this. We write it as 1, 2, 2. Okay? So these are now integers. We would not write this. Okay? So for example, if you had A equals, so there's another example. So here, I'll do it over here. So if A is 16 and B is 4, first thing I want to do is reduce it. I can divide both the top and the bottom by 4. I can divide this by 4. And that's definitely not the way I wrote that. So let me write it like this. I could divide this by 4. Actually, maybe this will even be better. I can multiply this. No, I'm not going to do that either. Sorry, guys. I'm going to divide. I'm going to divide this by 4, and I'm going to divide this by 4. And I end up with 4 over 1. That's as simple as I can make this fraction. So my odds against would be 4 to 1. I just take the top number and then the bottom number. If I want to find the odds in favor, I just flip everything. So if this is the odds against, what I'm going to do is I'm going to say, well, the 16 was the number against it happening. The 4 was the number that was for it happening. So I would just, the odds for, I would just flip it. I would say it's going to be B over A. Still simplify. And I get 1 over 4. So my odds in favor would be 1 to 4. Okay, so let's do an example. Well, first we need to do this. So the payoff odds against an event A occurring are the ratio of the net profit if you win to the amount bet. Basically what we're saying is that if I bet, like let's say I bet on a horse and the odds were 2 to 1, okay? That means that for every dollar, here, let me write this down. For every dollar I bet, because that's betting $1, if I win, then I get $2, which is coming from here. Okay. Plus I get my dollar back that I bet. I don't lose my dollar. That would be even odds. What if I said that my odds were 5 to 3? So now that means for every $3 I bet, if I win, I win $5 plus I get back my original $3. Okay. So that's what this means. The net profit. So net profit means that if I bet $1, well, let's say here, I bet $3 and I got 5. 5 is my net profit. That means that if I take away from what they give me what I spent, then I would get $5. Notice I would get back if I won this bet and the odds were 5-3, I would get $5 from the odds, $3 from my original bet. That adds up to $8. So the net profit is $5 because that's how much I win. But my whole, not my profit, but the amount of money that I get, that someone gives me, the person who's paying me, right, they're going to give me $8. They're going to give me my original $3 back plus that $5. So that's what the net profit to the amount bet means. Okay, let's do an example. I think that always helps. So if you bet $5 on the number 13 in roulette, your probability of winning is 1 out of 38. But the payoff odds given by the casino are 35-1, which basically is the same as 1/35. So which one's bigger? 1/35 is definitely a bigger number than 1/38. But if I had 1/38 and I won, I would get $38 plus my $1 back. Whereas with the 35-1, for every dollar, I would get $35 plus my $1. So actually, the odds here favor the casino, right? Because if it was the odds of 1/38, I would have a chance of making more money. So they're always kind of lowering the odds so that the odds are in favor of them winning. So I don't know if you've ever heard that the house always wins. That's like the casino will always make money because over time, even if someone comes and wins a lot, one person comes and wins a lot, because so many people are playing, the other amount of money is making up for it. Let's see if that makes sense. So first it says find the actual odds against the outcome of 13. So actual odds against, we would have to say the probability of A bar over the probability of A, right? So A is the outcome of 13. We can just write 13. Not A. So not A would be every other number. So 1, 2, so on, up to 12. Skip 13, 14 to 36, I believe. And then I think there's a 0 and a 0, 0. I think that's what is on a roulette wheel. So, which adds up to 38 numbers. So we can say that the probability of A bar is going to be 37 over 38. That's the probability. There's 37 numbers that are not 13 out of 38 numbers. There's only one number that's 13. So the probability of it being 13 is 1 out of 38. And depending on how your algebra is, there's many things we can do, but one way we can do it is we can multiply the top and the bottom by 38, because 38 over 38 is really just 1. So I'm really just multiplying by 1. 38 divided by 38 is 1. So I can cancel this with this, and I can cancel this with this, and I would get 37 over 1, which gives me 37 to 1 odds. Okay, so look at the difference. If I bet $1 and I won, I would get $37 plus my $1 back, so 38. But with 35 to 1 odds, if I bet $1, I would get $35 plus 1, which is 36. So every time we play, the odds are not in our favor because they're not equal odds. So the actual odds would be 37 to 1. And this is exactly what they did, okay? Now, let's see what this says. If we bet $5 on the number 13, and my probability of winning is 1 out of 38, but the payoff odds are given by the casino as 35 to 1. So we're going to use what's given by the casino, because that's the odds they're giving us, even though we can complain, but they're not going to do anything, right? So how much net profit would you make if you win by betting $5 on 13? So my odds are 35 to 1. So for every dollar I bet, I make 35. So if I bet $5, basically I'm multiplying this by 5. So I also have to multiply this by 5. And that gives me 175. So if I bet $5, I would get back my net profit would be equal to $175. My gross is what they call it. My gross profit would be equal to the $175 plus the $5 that I paid. So that would be $180. So the difference between gross and net, if you've ever had a job, let's say your job pays you $10 an hour and you work 20 hours and you made $200 and they take out taxes, okay? So your gross amount is before they take out taxes. The net amount is after. So probably I wouldn't say gross profit. I would just say gross amount, because the net is your profit. The gross is the total amount of money that you'll be given. But you already paid $5 for this bet. So the net, so you're going to get your $5 back plus the 175. Okay. And I'm pretty sure that's exactly what this says. So for a bet of $5, the net is 175, which is 5 times 35. The winning bettor would collect $175 plus the original bet. So after winning, the total amount collected would be 180, which is what we said, but the net profit is only 175 because $5 of that money was already mine, right? if you bet $5 on the number 13 in roulette, you're winning. Your probability of winning is 1 out of 38, but the payoff odds are given by the casino is 35 to 1. Same problem. C says, if the casino was not operating for profit and the payoff odds were changed to match the actual odds against 13, how much would you win if the outcome were 13? So now we're going to go to the actual number. So A is going to equal 1 over 38. And A complement is going to equal 37 over 38, right? Because every number but 1 is the complement of 1. So if I say the probability of not A over the probability of A, we would get 37 over 38, which is 1 over 38. And now I'll show you the different way. So this is the way you probably learned. This is 37 over 38 divided by 1 over 38. And most people learn this to divide fractions as keep, change, flip. Keep, change, flip. So what does that mean? It means I keep the first fraction exactly the same. I flip, I change this division to multiplication, and I flip the second fraction. Okay? And then I can cancel 38 with 38, and I get 37 over 1. So my odds are 37. So my odds are 37 to 1. Okay? How much would you win if the outcome were 13? So now with the new odds, what would I win? So I'm going to multiply this by 5, and I'm going to multiply this by 5. So if I bet $5, then it's 35, 185. I would get a net profit. So my net profit is equal to $185. My gross, so the gross amount, which is the amount that I would get from the casino, would be the 185 plus my original $5 bet, which equals 190. Okay. Now, as you can see, we haven't used StatCrunch. This section is really just calculator section. There's really nothing in StatCrunch that I've seen that can help here. I'll take another look, but I don't think there is. And so here's their solution. If the casino were not operating for profit, the payoff odds would be changed to 37 to 1. That's exactly what we said. Which are the actual odds against the outcome of 13, with payoff odds of 37 to 1. There's a net profit of $37 for each $1 bet. So if I bet $5, I multiply this $5 times this 37, and I get $185. So the casino makes its profit by providing a profit of only 175 instead of 185 that would be paid with the roulette game. That is fair, instead of favoring the casino. So basically they're saying the odds are this, we're gonna make them a little more in our favor. We don't want it to be, exactly correct. We want to be, how can I say it? We want to always make sure that we're winning. And by just changing the odds that a small amount, which is the same as changing the probability, we win less money. The casino wins more. And that is the end of odds 4.1. Please feel free to ask any questions that you may have if I didn't answer them. And
I think that's all I have to say. Have a good one.